In the previous lecture, we have seen about the rank correlation coefficient. Okay, so we have seen how to find the rank correlation coefficient when we have non-repeated entries and when we have repeated entries. Okay, so using the concept of repetition and the average rank, we have solved the problems. Okay, now we'll try the next. Okay, so next is finding the relation between the attributes as treating the attributes as the variables. And this is a very important concept in machine learning and data analysis. Okay, so most of the times we start with this concept only. Okay, so when initially we start analyzing the data, okay, first we try to find out are they related. Okay, so if they are related, up to what extent they are related, and once we know that there is a relation, or we have the confidence that yes, there might be a relation, and then we try to find out what is the relation. Okay, so this way we try to do. As in the beginning only, beginning of the statistical techniques, I have taken an example. When we go to the malls, or when we go to the mega marts, okay, and we purchase, and then after a few days we start getting the messages from the mega mart about the particular section, about the particular uh, a particular area of that mega mart, and they go on promoting the things. Now the question is how they get it. Okay, so the answer is they relate your visits. Okay, they find try to find your visits, your time spent in the mega mart, and the area from where you have purchased more. Okay, so actually we cannot guarantee that there will be always a relation. Okay, there will be always a relation between your visits to the mart and then purchase in the particular section. Okay, may possible, may not be possible. Okay, but okay, they try to find it. Okay, so the quantity which we know exactly it varies is called a variable, but the quantity which we are not sure is called attribute. Okay, so in data analysis, most of the times we have attributes, we don't have the variables. Okay, and that's what we do. We convert these variables, we convert these attributes to variables. Okay, so for example, what can be an attribute or what can be a variable? Okay, so when I consider the distance covered by any vehicle, moving vehicle or moving object. Okay, so distance is a function of time. If I consider speed, okay, so that way it is going to be, so whatever your speed, whatever you take the time, and then distance will be the function of this time and velocity. Okay, so there, this is a variables. Okay, so velocity is a variable, time is a variable. These are independent variables, and moreover, the distance cover is a dependent variable. Okay, but now think of the height of the fathers and the height of the their daughter or son. Okay, so can you have the fixed relation? We cannot guarantee. Okay, we say there may be. Okay, but we cannot guarantee exactly what can be, and that's why these are called attributes. Okay, so this is the basic difference between the variable and the attributes. Okay, so variable follows a pattern, whereas the attribute may or may not be. Okay, so we cannot say it will follow always. Okay, may or may not be. Okay, and that's why in the data analysis or in analyzing this data, we always have to consider the attributes as a variables. Okay, so we treat attributes as a variables, and once we know these are the variables, initially they are attributes, so we cannot guarantee that there is a fixed relation. So we try to find out what is the relation if there is. Okay, provided the condition, if there is any relation, then we try to find out it. Okay, and the tool we are going to use is a regression. Okay, so the tool we are going to use is a regression. So today we have to see about the regression. basically we'll start with the linear regression. Okay, so regressions are many types. We have the linear, non-linear. In non-linear, again, we have the quadratic, cubic, and splines. Okay, and moreover, these regressions are used in many ways. Many times it is used. Okay, so it's also used in predictive analysis. Okay, so it's also used in predictive analysis. Suppose you are having a trait, you are following a trait, and then you are getting that yes, it is going to somewhere. Then you can predict what is going to happen in the next. Okay, so that's why the regression tool is very important. Okay, so as you might be, I have an idea about the interpolation and extrapolation. Okay, so interpolation and extrapolation is in the variables. So when you have the variables, then you consider the interpolation analysis and the extrapolation analysis. But when you have the attributes, we go with the regression. Okay, and that's why most of the times when the data comes to us, it is the raw data, it is the attributes data, and that's why the interpolation is not a good choice, but the regression is, and that's why we move on to the regression analysis mostly, and most of the times the regression analysis is used. Okay, now here we consider the two attributes, we convert them to variables, and now onwards variables. So we consider two variables. Okay, but that can be extended to a lot. Okay, so whatever the number of attributes we want to consider, we can consider, and we may have a good regression analysis for this all the variables. Okay, so first let us try to understand what is the regression. So in regression analysis, we have to go with the coefficient of correlation. Now we have to consider the regression. We'll be considering mostly the linear regression. So here in regression, we have two things. Okay, so when I consider any variables x and y, so what is the best relation that I can have? I can write as y is equal to ax plus b, or I can write as ax is equal to ay plus b, and these both represent lines. So this is called as linear regression. Okay, so now the question is, we don't have only one value of x or only one value of y. We have the different values of x and corresponding values of y. And now I want to find out what is the relation between these two data sets. Okay, so this is data x and we have data y. So we have to find out what is the relation between these two data sets, and then how we are able to get the formula for this regression. So what we have here, we have to write how we are able to get the relation between the x data and y data. So when it is a variable, it is easy to write, but when it is the attributes, then we have to think more. Okay, so first we have the line of regression. The line of regression of a y on x. Y on x. Okay. So what we have? We have this data. Okay, x data and y data. And now I want to find out if there is any relation. What is that relation? Okay. So we have the line of regression of y on x is given as y minus y bar is equal to byx x minus x bar. So please be careful for writing this byx. Okay. So that is equation 1. Okay. What these terms are? Y bar we know, x bar we know. What this term is? This is the new term that we have encountered now, and so we need to understand what this term is. Okay. So where we'll be having y bar is equal to summation y upon n, x bar is equal to summation x upon okay. So this is summation x upon n. Okay. And what you will be having this term? This is byx. Okay. So what is byx is? It is r into sigma y. Okay. Sigma x. So what we know is this is the capital sigma. This is the small sigma. Okay. So this we use for the summation, and this we use for the standard deviation. Okay. So this sigma y upon sigma x. These are the standard deviations. Okay. So is the regression coefficient. Regression coefficient of y on x. Okay, this is the regression coefficient of y on x. Now, what is r? What is sigma x, sigma y? Okay, that we have to see. Okay, so what we know where and r is equal to. So, what is r? R we have seen that it is summation xi minus x bar, yi minus y bar upon. We have seen this is a square root of okay summation xi minus x bar square into summation yi minus y bar square. Okay, or and what is sigma x is? So sigma x is square root of summation xi minus x bar bracket square upon n. So n is also in the square root. And what is sigma y? So sigma y is square root of summation yi minus y bar bracket square upon n. Okay. So what you can do is if you write this here in the definition of byx, then you can have the another formula also. Okay. So what is the formula we have? See, byx is what? It is r sigma y upon sigma x. So sigma y I can write, sigma x I can write, and I can write this r. Okay, so let us try to simplify what we have. And we have byx is equal to, so r sigma y upon sigma x. So we know dabba, we know sigma. So this is dabba and this is sigma, the mirror image of dabba. Okay, but be careful while writing 6 and sigma. Okay, so 6 slightly we write see we write 6 like this, so slightly you have to turn it down. Yeah, so you can have this is going to be sigma, this is going to be 6. Yeah, so please be careful for the notation. Yeah, now what we'll be having, see this r, so r is summation xi minus x bar yi minus y bar. Okay, upon this is going to be square root of summation xi minus x bar square root of summation yi minus y bar square sigma y. So sigma y is square root of summation yi minus y bar square upon n. Sigma x. So I can write this as n upon square root of summation xi minus x bar square. So you can see what I'm able to cancel. So this n will get cancelled. Okay, n will get cancelled. This term will get cancelled with this term. So I can simplify this as also Vyx is equal to summation xi minus x bar yi minus y bar upon this square root and this square root will have. So summation xi minus x bar square. Okay. So either you calculate Vyx by using this formula or you calculate Vyx by using this formula. Okay, so either of this you are able to use. Okay, so this is these are the basic formulas. Okay, so I hope you are familiar with the standard deviations. So where sigma x is, I say sigma x and sigma y are standard deviations of x and y respectively. Okay, so these are the standard deviations of x. This is the standard deviation of x. This is the standard deviation of y respectively. Okay, so either we can use this formula, okay, or we can use this formula. Okay, and now we can have the next. So we'll be having the second one. Okay, so the line of regression of x on y. Okay, so we have to consider next the line of regression of x and y. So as we have seen, the line of regression of y on x. Okay, so this is y on x. Okay, and now we have to see x on y. Okay, so what we have here, the line of regression of x on y is given as. So what you'll be having here, you have x minus x bar is equal to bxy into y minus y bar. Okay, so that's what we have. So this is the line of regression, okay, of x on y. Okay, and you can see what is bxy is. So where bxy is equal to r sigma x sigma y, or this is we can simplify xi minus x bar yi minus y bar upon summation yi minus y bar square. Okay. This is the regression coefficient. x on y. Okay, so as I have proved this formula is same as this formula. So similarly, you can prove this. Okay, so that's what we have. That's why I'm writing this. And then you know what is sigma x, sigma y, x bar, y bar. That already we have written in the previous case. Okay, or I'll write it here. So where r is equal to sigma xi minus x bar yi minus y bar upon square root of summation xi minus x bar square into summation yi minus y bar square. What is sigma x? Okay. So we have sigma x is equal to square root of summation xi minus x bar bracket square upon n, and sigma y is equal to square root of summation yi minus y bar square upon n. Okay, so that's what we have. Using this, we are able to write the line of regression, and we are able to find the line of regression on x on y and y on x. Okay. Do we have any doubt up to this? Because once you understand the formula, rest is going to be calculations. Okay, and we know how to calculate R. Okay, so once you are able to calculate R, you are able to calculate this regression coefficient, and then you are able to calculate the line of regression. Any doubt up to this? Okay, good. Okay. Any doubt, Arti? Harshal Rathod, any doubt? Good. Okay, Lakshit, any doubt,
No, sir.
Lakshit?
No, sir.
Okay, Prachi? Okay. So we are clear with the formula now. Okay, that's good. Now it depends on us what formula we want to adopt. Okay, so what happens in some examples? Okay, we have to calculate both the line of correlation, both the lines of regression. Okay, so when you want to calculate both the lines of regression, then this will give you only one. Okay, so we have to make the table which we did for capital R. Sorry, small r. Okay, so here we can calculate small r, and if you can make the table for small r, everything is same now. Okay, so that's why whatever the table we have done for this small r, the same table we have to do here. Okay, but if there is only one line we want to find out, then it is more easy. Okay, so only these terms we have to calculate. We can skip one term. Okay, but anyhow we have to calculate this two. Okay, so let us try the example. Okay, so what we have here. So let's have an example. So before that, we'll try to understand the procedure, what we have to do, and how we are able to do it. Okay. So this is a procedure to find the line of regression of y on x. Okay. So I want you to write down this procedure. So right here. if I want to find out the line of regression of y on x, what we have to do is we'll write the equation of line of regression of y on x, and then we need to find this dyx. Okay, so what we have to do is we have to prepare the table. As I said, the table is very similar to what we used to prepare for coefficient of correlation. So you can see the same we have x, y, x, small y, x into y, x square and y square. If I want to find out only this line y on x, then only x square. If I want to find out x on y, then we have to calculate y square. And then rest of this we have to calculate, and then this sums. Okay, once you know this all, we calculate or we put the values in the formula for byx. Once we calculate byx, then we put the value of byx in the line of regression, and then we have to simplify the equation in this form. So as we want the line will be of this form. So we have to find the line of this form. Y is equal to ax plus b, where a and b will the constant obtained by simplification. Okay, so is this procedure clear to you? Have you got this procedure? Okay, so good. Now we'll think of the next. Okay, so what we have here, we'll go for the procedure to find the line of regression of x on y. So x on y will be very similar to this. Okay. So we have the procedure to find the line of regression of x on y. So you can see again it is very similar. Yeah. So here only thing is that instead of x square we have to calculate y square. Okay. But if these are only one equation we have to find out, then x square or y square we have to calculate. But if I want to find out both the equations, then I have to write this all table, and we have to find both of this. Yeah. Now once we are thorough with this procedure, we'll go for the example. So please write down this procedure for line of regression of x on y. So if you are done, then we'll go for the next. So once you are done with this, then tell me. We'll go for the example. If you are done, then tell me. We'll go for the example. Are you done with this? Are you done with the steps that I have written here? Okay. So let's have an example. So the important formula that you need to understand is this line of regression. Then we need to understand the coefficient of regression, okay, or regression coefficient. Then R and sigma we know. Okay, so let's have an example. So I hope you are thorough with the steps now. Okay, so we'll try to have an example. So we have an example here. Find the equation of line of regression. Yeah, y on x. So please be careful. What we want to find out is y on x for the following data. Okay, I'll extend this question as, okay, also find the line of regression of x on y. Okay, so I'll extend this question. So it was only to find the line of regression of y on x, and now I want to find the line of regression x on y also. Okay, so both the lines we have to find in this example. Okay, so as I said, we want to find both the lines. So let us have the table. Okay, so what we know is here is the solution. Okay, so let's see the line of regression of y on x is given as. So what is that? Y minus y bar is equal to Vyx, and here we have x minus x bar. This is equation 1. Okay, so where we have this Vyx. So Vyx is equal to, I can write this is summation xy upon summation x square. Okay, so you can see this formula. Okay, we want Byx. So you can see this is summation small x small y, and this is a small x square. Okay, so we can write, or if you don't want to write this directly, you can write the formula as. Okay, so you can write this formula as summation xi minus x bar into yi minus y bar upon summation xi minus x bar bracket square going to be 2. Okay, and what we know is x bar. What is that? Summation x bar upon n. Y bar. So what is that? Uh, Here we have to be careful. Okay, so summation y on n. And what is n? N is equal to number of observations. Okay, so here, what is the value of n? How many observations we have? 1, 2, 3, 4, 5, 6, 7. So we have 7 observations here. So the value of n is 7 here. Okay, n is 7. Okay. Now what we have, the line of regression of x on y is given as. So what is the line of regression of x on y? So it is x minus x bar is equal to dxy and y minus y bar. This is the next equation where what is dxy? So it is going to be summation xi minus x bar yi minus y bar upon summation yi minus y bar bracket square is equation 4. Okay, so now we have these four equations. Okay, so x bar and y bar again already I have mentioned. So we have these four equations. So first we want to find out second and fourth, and then we are able to find out first and third. And so that's why we must write the formula first so that we can understand what exactly we want to calculate. Okay, the benefit of writing formula first is we will know what exactly we want to calculate. So looking at this formulas, what we have to do is I have to first calculate xi minus x bar. So for that I need to know what is x bar. If I know x bar, then I am able to calculate xi minus x bar. Then I have to calculate y bar. So I will know what is yi minus y bar. And then I have to square this term. And again I have to square this term also. And I want to find the product of these two terms. Okay, so this is how we have to decide the steps and the columns of the table. Okay, so what do we have here? Consider the following table. Okay, so what is the table we have? So what is given to us? X is given, Y is given. We want X minus X bar. So this is Xi minus X bar actually. Then we want Yi minus Y bar. Then we want the product of these two. So Xi minus X bar and then product with yi minus y bar. Then we want square of this. So xi minus x bar square, and we have yi minus y bar square. Okay, so this is what are the columns that we want. Okay, so we draw this. I hope you are making table with me. So please have this table. So this is the same table as we used to do for the coefficient of correlation. Okay, small r. Please make this table. So your table should be very proper so that you will not miss any entry or you will not miss any calculations. So we are given number of entries to be 7. So the last row we want for the summation. Okay. Now see the observations that we have. Okay. So what are the observations given to us? We can have 5, 6, 7, 8, 9, 10, and 11. Then 11, 14, 14, 15, 12. Okay. So we have this is 5, 6, 7, 8, 9, 10, 11. Okay. Now the sum of this immediately. So it is 11 and 14, 14, 15, 12, 11, 14, 14, 15, 12, 17, and 16. So we can check this one. Yes. So 11, 14, 14, 15, 12, 17, and 16. Okay. So what we have from above table. We have. So what we are having. First, I want to know what is X bar. So I should know what is the sum. Okay. So here we can write the summation. So please give me what is the summation X and what is the summation Y. What is the 56 and 99? Okay. So that's good. We have this is going to be 56 and this is 99. Okay. So what we know about X bar and Y bar. So we have X bar is equal to summation X upon N. So it is 56. N we have already seen that is going to be 7. So it is going to be 8. What about Y bar? So Y bar is summation Y upon N, and hence it is 99 upon 7. So give me what this average is. What is the average Y or Y bar? 14.14. Okay, that's great. So we can have this is 14.14. Okay. So now once I got these two values, I am able to calculate the remaining table. So what you'll be having this see 8 is the average. So we have this is going to be 0, 1, 2, 3 with minus, and this is going to be 1, 2, 3. We don't want the sum of this. So we want square 9, 4, 1, 0, 1, 4, 9. We want a square of this. So it is going to be 10, 10, 28. Okay. Now I want this yi minus y bar. So here we have this is minus 3.14. This is minus 0.14. Also having minus 0.14, and this is 0.86. So this is minus 2.14. What this is going to be? This is going to be 2.86, and this is 1.86. Okay, so we want the sum of this. Now we have to find what is squares. Okay, so I want you to find out the squares. So please find out this terms and then tell me what we have. We are interested in this sum and this sum. So summation this term and this term. So when you have these entries, then only you are able to get it. So let me know once you are ready with this terms. I hope you are calculating with me. I'm also calculating. So are you ready with the table? Yeah. Okay. So good. Great. Now check your values with my table. So is that what you got? Okay. So I hope all of you got these values. Okay. That's great. Okay. So you got the same values. Okay. May possible that last few digits after four decimal places you may have got the different, or after three decimal places you may have got the different. But your value should be nearby this only. Okay. So you got the values. That's good. Now let us calculate the remaining part. Okay. Good. Okay. So let's calculate remaining part. What is remaining here? So we got this term, and hence from equation one. From equation 2, we have byx is equal to, what is bys? Summation xi minus x bar yi minus y bar upon summation xi minus x bar square. So what this value is here? Byx is going to be 19, and this x square is going to be 28. So give me this value. What do you get? Now, what is the value we got for byx? 0.6785. All of you are getting the same. Anybody else got? Yes, 0.6785. That's good. Okay, so 0.6785. Okay, so we got here. This is 0.6785. Okay, so once you got the value of byx, okay, so you got a value for byx, and hence we can say byx is equal to 0.6785. Okay, and now we are able to use this in equation 1. So what you can say is, from equation 1 we have, so what you'll be having, y minus y bar, so it is going to be 14.14 is equal to byx, so 0.6785, and x minus x bar, so that's what we'll be having. Now we have to simplify this equation. Okay, so we got all the terms here. Now simplify this equation. So what you'll be having, y minus 14.14. So here we'll be having 0.6785 times x minus 0.6785 times 8. Okay, so you got y is equal to 0.6785 times x minus 0.6785 times 8 and plus 14.14. So you please give me what this constant is. So we got the line of regression of y on x is y is equal to 0.6785 times x, and then your this constant will be the constant you have to give me. Okay, so please give me this calculation. So what is the value you got for this? No, Akhilesh, we don't have to write the line like this. So we got the value 8.712, 714 or 712. Okay, so we can have this will get as whether this is plus or minus. This value you are getting plus 0.71. Okay, so what this value is, that doesn't matter the last digit, but this is the line that we'll have. Okay, so this is the line of regression of y on x. Okay, and now we have to find the remaining part x on y. Okay, so we also have to find x on y, and hence to find x on y. Okay, now we consider. Okay, what we have to consider is bxy. So what is bxy? Summation xi minus x bar yi minus y bar upon summation yi minus y bar square. Okay, and this we know is going to be 19, and this value we have calculated. What is the value we got is 26.8571. Okay, so this is the value 26.8571. So give me this value what you get for byx. Okay, so bxy is equal to what is the value of bxy? You have to calculate. Okay, so what is the value of bxy? Find 7074. That's good. Okay, so this is 0.7074. So we got here 0.70. Okay, so we have to be very careful for writing 0.7074. Okay, once I get this value of bxy, then we consider equation 4. This was equation 4. Okay, and now we have to consider equation 3. Okay, so from equation 3, we have, what is the equation 3? It is x minus x bar is equal to 0.7074 bxy into y minus y bar. So it is going to be 14.40. So we got x minus 8 is equal to 0.7074y minus 0.7074 into 14.14. Okay, so you got x is equal to, what this term is, 0.7074 y minus 0.7074 into 14.14, and you will be having plus 8. Okay, so we can have the line of regression of x on y is, what will be having, x is equal to 7074y. Okay, and now you have to give me the value of this constant. What this constant is going to be. Okay, so what is the value of this constant with the sign you have to give me? Minus 2.0026. Okay, minus you are getting three different values. Okay, so please check what is going to be more correct. Four values. This is the fourth value that we are having. All different values. You cannot have all different values. So that means you are not calculating properly, I think. Okay. So we accept this point 2.0026. Okay. So we can have this is minus point minus 2.0026. Okay. So this is the line of regression we have. Okay. So this way we are able to calculate the line of regression on x on y also and y on x also. Okay, and now you can see the table that we have used is same as the table used for small r. That is the coefficient of correlation, and we know here we can involve the coefficient of correlation if you want to use that formula. Okay, with sigma, then you need to calculate r sigma and sigma x and sigma y, and then you are able to get the value. So you can use this formula directly or this formula also, that doesn't matter, you will get the same value. But if you want to use this formula, this your calculations will be the smaller ones. Okay, so you can use this directly and have this. Okay, so do you have any doubt in this example? Okay, okay, that's great. Okay,